Hello, welcome to Algebra 1 with Miss Betsy. Today we're going to keep on doing some work with word problems, and today we're going to be focusing on mixture problems. And these are the type of problems that you have if you say, okay, how much oats do I have to mix with corn? Do I have to mix with barley to get a particular feed mixture for your animals? Or it might be back when you used to create your own mixes of nuts or candy. You know, I want 15% pecans and 40% cashews, and whatever the remaining mix is, 45%, I guess it'd be 45% of peanuts. And how am I going to mix all of these together, and how much is it going to cost? These are the types of problems that we're going to be working with today. Now, if you're tracking with me, I'm in the second edition of Algebra 1 for Christian schools. It's published by Bob Jones University Press. The third edition covers about the same material, it's just in different order, so just make sure that you're watching the same lesson, same video that your lesson covers. So let's go ahead and pray and see what our lame joke is for today, and then dive right into these mixture problems. God, you are awesome, and I stand in amazement and wonder at how much you love us and at your involvement in our lives. Lord, I ask that you would help us to comprehend what we need to in order to be able to figure out how to work these mixture problems. Lord, those who are on the other side of this camera for me, help them to understand and help me to communicate clearly. And I thank you for that. I pray in the name of your Son, Jesus. Amen. Okay, I almost forgot the joke. This one is a joke about a cat. Actually, I'll get this second one also. The first one says, what kind of a cat likes to bowl? You know, in a ball, go and throw that ball at the pins. Well, of course, it would be an alley cat who loves to bowl. And this one here says, what is a French cat's favorite pudding? Chocolate mousse. And mousse is spelled very much like mouse. So I guess he likes chocolate mice. Anyway, we are on page 169. We're talking about mixture problems, and we're going to see what we can do here. And it says, mixture problems involve the combination of different substances. To solve each problem, make a table similar to those for coin and interest problems. This is what we've been doing for a couple of weeks now. Read the following problem and collect all the necessary facts. And if you just flip over to the next page, on page 1671, it says, solving mixture problems. Read the problem carefully to find the unknown quantities, translate each into an algebraic expression. That really is a huge part of the secret to being able to solve these algebra word problems, is taking the time to read the entire problem, not getting all psyched out by the huge amount of information or all the sentences that are in there, but break it apart into little manageable pieces. It's like it's that ultra dumb joke. How do you eat an elephant? I think I probably used this just recently. How do you eat an elephant? You eat an elephant one bite at a time. And that's what we do with these word problems. So, we have a feed store owner who wants to mix corn and barley to make 150 bushels of silage additive for cattle feed. The corn costs $2.40 a bushel, the barley costs $2.20 a bushel, and this is a really old book. How many bushels of each grain should he mix to yield an additive worth $2.34 a bushel? So, what is he saying? What's the crux of this problem, or the thrust of the problem? It's, okay, I've got corn and I've got barley, and I want to mix them together so that my expense for my cost for that mixture is $2.34. And I want to end up with a total of 150 bushels of this mixture. And you remember back to when we're talking about coins, we say, okay, if I have 12 coins in my hand, I know some of them are dimes and some of them are nickels. I can say I've got X nickels. Well, 12 minus X, or the total minus my unknown, gives me the number of the second type of coin. And that's exactly the principle that we're going to use when we are working with these mixture problems here, particularly this one. So, What do we have? We're going to have 3 different lines that we're going to be working with here. 3 different categories. We are going to have corn, and we're going to have barley, and we're going to have our mix. And we're going to have our mix. And we're going to want to have the number of bushels. We're going to want to have the price per bushel and the total price. So we have number of bushels, and I'm just going to put how many bushels. And we're going to have the price per bushel. And then we'll have the total price. And we want to come up with how we're going to define our variable. So let's look back at this again. And it says 150 bushels of silage. One is going to be corn and one is going to be barley. And it doesn't matter which one you're going to use. Your book says let's have corn be the variable, let x equal the bushels of corn. So we're going to go ahead and just follow their example so that you can track right along with the book if you like to. What's the price per bushel of corn? You look back at your problem and it says corn costs $2.40 a bushel, 2.40. So what's the total price going to be if you have X bushels at $2.40 a bushel for corn? Well, that's easy. That's going to be 2.40x is going to be the price of the total number of bushels of corn. We don't know how many bushels we have. If it's 10, it's going to be $24. If it's 20, it's going to be $48. But we've got this representation here, this algebraic expression that we're going to be able to use to say however many bushels we have, when we multiply that by the price per bushel, that tells us the total price of the corn. And then we next have barley. And what's the price of the barley? I think it's $2.20. The price of the barley is $2.20 a bushel. And how many bushels of barley are we going to have? Remember, back in our problem told us we need a total of 150 bushels of silage, or of the mixture. So if we have X bushels of corn, we can say 150, which is the total, minus the number of bushels of corn that we have. That is going to be the total number of bushels of barley we have. Now, what's our total price for our barley going to be? It's going to be the price per bushel, which is $2.20, times the number of bushels. And I'm just going to write it in exactly like that. 220 times 150 minus x. Don't forget the parentheses. What happens if you don't remember the parentheses? Then you end up saying only 2.20 times 150, and you just say minus x instead of minus 2.2x. Now, mixture. What are we going to have here to fill in our chart? Well, our text tells us that the farmer wants the total price of his mixture to be $2.34. So that's easy. That's the price, not the total price of the mixture, the price per bushel of his mixture is $2.34. Well, how much mixture does he have? You're mixing corn and barley together to get 150 bushels. So the price of his mix is going to be 2.34. Now, I think I've said this maybe in another video. This is to my Algebra 1 kids that are right in my co-op classes. You can be using your calculators now. You're officially allowed to use calculators. So when you plug your 2.34, the price per bushel, times 150, you're going to end up with a total price for his silage of $351. Now, we filled out our chart. We have the corn, we have the barley, and we have the mixture that we're going to add his silage to, his animal feed. Now we have to come up with an equation that will allow us to say this quantity on the one hand is the same as this quantity on the other, and then we'll be able to solve an equation. So what in the world could we possibly do? Well, the number of bushels of corn plus the number of bushels of barley is equal to the total number of bushels, isn't it? So could we say x plus 150 minus x is equal to the total number of bushels of mixture we have? Well, yes, it's true, but it doesn't help us. Because when we solve this equation here, we have x plus 150 minus x minus x goes away, and you have the true statement that 150 is equal to 150, but that does nothing to tell us, to help us at all to determine what the value of x is. So while this is a true algebraic equation that we have taken from the material that we have, doesn't help us. So what else could we do? Well, the number of bushels doesn't help. Well, what about part plus part equals whole? This is a general formula that shows up all of the time in word problems. Part plus part equals total or equals whole. Now, if we look at this chart that we have here, what can we come up with? Well, part of the bushels of corn, part were barley, they made the whole, but that didn't do any good. Well, what about the cost of the barley plus the cost of the corn plus the cost of the barley equals the total cost of the mixture? Aha! That's going to work because we're going to have our variables on the left, and we're going to have just a plain number on the right hand side. I want to glance at this right quick and see what they're doing. Okay. Now, what are we going to have? We're going to have 2.4x 2.2 times $3.50. Now you notice I went ahead and put in 2.40 for $2.40. I put in 2.20 for $2.20. Do we need to have that when it comes down to multiplying? No. So I'm going to go ahead and just remove those. It makes our math a little bit easier. If you want to keep it as 2.40, 2.20, it's perfectly fine. I wanted to write it in so that it would be in recognizable, easily recognizable dollars and cents. But all we're going to be doing is we're going to take the total price of the corn, 2.4x, plus the total price of the barley, 150 minus x, is equal to $351. And did you hear what I just said? 351? That's not 351, it's $351. Now, we have decimal points in our equation, and you'll remember from section 4.7 that the way that we're going to clear this equation of decimals is to multiply both sides of this, because we only have one decimal point place here. We're going to multiply both sides of the equation by 10. And that has the effect of moving the decimal point 1 unit to the right, one space to the right. So we now have 24x plus 22 times 150 minus x is equal to 3,510. Now, this looks just like a normal problem. We're going to distribute to 22, and I'm going to look at the book rather than try and do the multiplication in my head or take the time to write it out. And 22 times 150 is going to be 3,300. Now we have 22 times the negative x, so it's going to be minus 22x is equal to 3510. Collect like terms to x, and we're also going to subtract 3,300 from each side, but I'm not going to, yes I am, 3,300. We subtract 3,300 from both sides of the equation. Minus 3,300 is equal to 3,510 minus that 3,300, which keeps our equation in balance. And that's why I try to use the different colors here as we're still working on making sure that we keep our equations balanced. We now have 2x is equal to 1,800 and that just doesn't seem to be right. What have I done wrong? 2x is not equal to 1,800, is it? It's equal to 210. I would love to know how in the world I ended up with 1,800. Wow, that's a little bit scary. 210. Very interesting. Okay, 2x is equal to 210. We divide both sides of this equation by 2, and we end up with x is equal to 105. Now, is that all that we need to do? Well, what does our problem ask us? Our problem asks us how many bushels of corn, how many bushels of barley. X is 105, so that's the number of bushels of corn. I'm going to just put bushels of corn, and 150 minus x, 105. 150 minus 105 is 45 bushels of barley. And that right there is the answer. And if you wanted to check this, you could go ahead and put 105 back in for x. You could put 45 back in for the number of bushels here. It would end up being 45, but you could go ahead and take this value here of x, substitute it into the original equation that we have, and then you would be able to verify that if you do in fact use 105 bushels of corn and 45 bushels of barley, that you would end up with 150 bushels of mixture with a cost per bushel of $2.34. So that is the example, the first example that we have in our book. So now let's see what this says. 40% off Crazy Steve's birdseed. Percent is changed to decimal form by dividing the percent by 100. We've talked about this in class. We'll do it again right now. When you have a percent number, we've done these in other books, you cannot put percent with that percent symbol in our charts that we're working on. You can't multiply by percent. You have to convert percent into a decimal number, and percent means per 100. So if you have 3%, that's 3/100ths, or 0.03 expressed with the decimal number. Okay, so let's go ahead and see number 2, example 2. This says nickel silver, often used for coating tableware, or forks and knives and spoons. Tableware is an alloy containing 15% nickel along with copper and zinc. How much pure nickel must be melted with 70 pounds of nickel silver to make an alloy that is 20% nickel. And you're looking at that and your brain might be saying tilt, tilt, tilt. Get where that tilt comes from. It comes from the old pinball machines that if you'd shake them and get them off level, it would say tilt and it would erase your score. It would stop your game. Which now just tells you beyond a shadow of a doubt that I am not 20 anymore. Okay. How much pure nickel must be melted with 70 pounds of nickel silver to make an alloy? So the first thing we want to do, of course, is figure out what in the world's going on. Well, once again, it's a mixture problem. We have nickel silver, we have pure nickel, and we have the alloy, which is an alloy is the word that they use to describe a metal that is not a pure metal. Not just gold, it has something added to it. Not just copper, it has something added to it. Here we have pure nickel and nickel silver, I think, that we're combining. Isn't that what it said? So the question is, how much pure nickel should be added? So we're going to have, let X be the amount of pure nickel. So once again, we're going to have 3 lines of information. We're going to have pure nickel, we're going to have nickel silver, and we're going to have our alloy. And I'm looking for my other marker that rolled way out of view of the camera. So we have nickel, we have nickel silver, and we have what we're going to use as our alloy, which is what we are trying to arrive at. So what pieces of information do we have? It's going to be very, very, very similar to how we did our silage problem. But this time we're going to have, let me get this right here, but it's going to deal with percentage. Let's look at this problem again. It says, how much pure nickel must be melted with 70 pounds of nickel silver to make an alloy that is 20% nickel? So, like I said, X is going to be the amount of pure nickel. So, X is the nickel. 70 minus X is going to be the nickel silver, because we know that we're being told that we want to make 70 pounds. Okay, I just spoke that wrong. Make sure that you take the time after you read your problem. Make sure that you realize what you're talking about. It's hard to keep everything in your head. How much nickel has to be added to, this says, 70 pounds of nickel silver to make an alloy. So we're going to take, we don't know how much nickel, but we know we're going to add that to 70 pounds. So how much alloy are we going to have all together? We're going to have 70 pounds of nickel plus however many pounds of nickel silver. So that's going to be, I'm just going to put X plus 70. I think your book may say 70 plus X. So this is going to be pounds. What are we going to have to do next? Well, let's look back at our problem. What other piece of information do they give us? Well, they're talking about percentages here. 15% nickel is what we want to end up with. Misspeaking again. Nickel silver, often used for coating tableware, is an alloy that contains 15% nickel. Okay? Nickel silver is 15% nickel. We want to come up with an alloy that is 20% nickel. What percent what percentage nickel is pure nickel going to be? That's what the kicker is in this problem here, is that the percentage of nickel in pure nickel is 100%. And I'm glancing right down here. Let me just go ahead and change this order here, because I know some of you have a difficult time when the order of how I structure something on the board is different from it the way that it is in the book. And since this is a somewhat challenging problem, let me make sure that I'm doing everything exactly lined up, following the same method they are. We're going to have the pure nickel here in the middle. And our question was, how many pounds of pure nickel are we going to add to 70 pounds of nickel silver? So we have nickel silver, and we have 70 pounds of that. We don't know how much pure nickel we're going to have to add, but we do know we have 70 pounds of nickel silver, and our alloy, or the mixture, is going to be 70 pounds plus however many pounds of pure nickel we end up adding. Now, they also have, so this right here is what we're going to call the pounds of alloy. Okay, pounds of alloy is the nickel silver is an alloy. The pure nickel technically isn't an alloy, but we're going to call it the alloy. The alloy, of course, here, the mix that we end up with is a higher percentage of nickel than the nickel silver originally was. So we've got the pounds. It might be better to just say pounds of metal here. Your book says pounds of alloy, but pounds of metal might just make more sense. The second column that we're dealing with is the percentage of nickel that we're going to have in this particular amount of metal. So this is going to be the percentage of nickel. Nickel silver is what percentage nickel? Well, we look at this again and it says it's 15%. 15% is not 0.51, it's 0.15. That's 1500ths is the decimal representation of 15%. They want the mix to be 20%. The nickel silver has a current percentage nickel of 15%. And how much nickel is there in pure nickel? Okay. How much gold is there in pure gold? It's 100%. When something is pure, we say that it's 100%. How do you represent 100% using a decimal? Well, this is 15%, this is 20%, this is 95%, 99%. What is 1%? 99% plus 1%, $1, or 1.00, represents 1%, or 100%. So you can simply express 100% by 1. There's no need to have 1.00. The number 1 itself is 100%, because anything less than 100% is a decimal number that's less than 1. So we now have the pounds of metal. We have the percentage of nickel that is contained in nickel silver, which is 15%. The percentage of pure nickel in pure nickel, which is 100% nickel. And we have that our alloy that we wish to arrive at, our mixture that we are creating, we want that to be 20%. Now, if we're going to, what's our third column going to be? If you look at your book, it says pounds of nickel. So let's see what they're talking about here. pounds when they're talking about pounds of nickel, the way that you find something, the amount in a mixture, if you know the percentage, is you just take the percentage given to you. So it's 15% nickel times the total number of pounds. 1% 100% nickel times X. 20% nickel times this quantity. Okay, so the first thing that you're going to do here is say 70 times 0.15, and I'm not even going to trust myself, or they're not even going to write this out yet. They're just going to say 15% nickel, 15% times the 70 pounds. That's going to be the pounds of actual pure nickel that is contained in this nickel silver. The next one is just going to be 1 times X. That's the amount of pure nickel. And then we're going to have 20% times 70 plus X. 20% times 70 plus X. And that is going to be the pounds of nickel that are actually contained in that final mixture, or that final alloy that we end up with. And just let me read this from the text, because this is a little bit different concept. Use the fact that the pounds of metal multiplied by the percent of the nickel gives you the pounds of nickel that are in that chunk of metal right there. That's how we ended up with pounds of nickel. Now we have to come up with an equation that we can use to solve so that we can determine the amount of pure nickel. So, what can we do here? Wouldn't it be true that the pounds of nickel silver, what are they saying? The pounds of nickel in nickel silver plus the pounds of nickel in the alloy mix would have to equal the total amount of nickel in the mix. What do you think about that? The pounds of nickel in the nickel silver, 0.15 times 70 plus the pounds of nickel, which is X, in the pure nickel, would have to be equal to the total number of pounds of nickel in the new mixture altogether. Now you're thinking, okay, it doesn't make sense. I would think the X's both have to be on the same side, Miss Betsy. Well, you cannot just key in on those X's. You have to understand that, okay, the alloy, this new mixture here that we want to be 20% nickel, that's going to be, what we have right here, again, is part of our nickel is in this nickel silver. Another part of our nickel is contained in the straight nickel that we add to the nickel silver to increase the percentage. And when you add those together, that is going to give you the total amount of nickel that you have in your final result. So that's how we've ended up with this equation. 0.15 times 70 plus X is equal to 0.20 times the quantity 70 plus X. Once again, we have an equation involving decimals that are in the hundredth place. So we will need to multiply both sides of this equation by 100. When we do that, we'll eliminate our decimals. 100 times 0.15 gives us 15 times 70 plus 100 times x is equal to 20 times 70 plus x. Let me take a second to verify that I've got that right. 1570, yeah. Now, what is 15 times 70? That is 105 plus 100x. 20 times 70, 1400 plus 20x. Okay. If we isolate our x on the left-hand side and our constant terms on the other side, we have 100x minus 20x I'm going to combine two steps here for you, plus 105 minus 105. Is equal to 1400 minus 105 plus 20x minus 105. Let's take just a second to look at this equation and make sure that you all are good with it. We want to isolate the variable on the left-hand side. We have a 20x on the right-hand side. So I subtract a 20x from both sides of the equation. So I have 20x that I have subtracted from the right-hand side, 20x that I've subtracted from the left-hand side. I also have 105 on the right-hand side of the equation, but I want to move all my constant terms to the right. So I subtract 105 both from the left and the right-hand side of the equation. And now we're going to be able to see what we end up with. 100x minus 20x gives me 80x is equal to 1295. And I'm looking at that and not knowing how that division is going to work out. But this says that I did something fairly seriously wrong. Okay? Who can tell me what I did? I did 7 times 15. 7 times 15 is 105. I neglected to add that extra 10 in there. So I actually should have had 1050 plus 100x. Let me go ahead and erase this. This video takes me too much time to redo it. So, what I'm going to do now is I'm going to subtract 1050 from both sides of the equation. 1050 minus 1050 plus 100x is equal to 1400 minus 1050 plus 20x. I won't even bother to combine the two steps. And I end up with 100x is equal to 350 plus 20x. Now, I want to subtract 20x from both sides of this equation, and I'm going to end up with 80x is equal to 350. Now if you're working ahead, you can see that that number is not going to divide evenly. We divide 80, both sides of this equation, by 80. And we have x is equal to, well, the tens can cancel, 35 over 8. Let's look at this. 35 over 8. What is x going to be? Well, x is pounds. I don't know about you, but I do know that if I'm weighing something or measuring something, I'm not going to say that it's 35 over 8 pounds. This is one where you're going to want to punch into your calculator so that you end up with a decimal number. When your book does that, you have that x is 4.375. Let me show you this. 35 divided by 8. 4 eighths are 32, and you have a remainder of 3, which means that you have 4 3/8 pounds. 1/8 of a pound is 0.125 pounds. So x here is going to be 4.375 pounds. Or, if you wish to say 4 3/8 pounds. So what's our question? Our question is, how much pure nickel do you need to add to 70 pounds of nickel silver so that the resulting percentage nickel increases from 15% to 20%? The answer here is if you take almost 4.5 pounds or 4 3/8 pounds of nickel, add that to the nickel silver, then the percentage of nickel contained in that resulting mix is going to be 20%. Okay? This was a long problem. Actually a long chapter. The mixture problems, some kids love them, some kids hate them. To me, you have coin problems, you have distance problems, you have interest problems, you have mixture problems. Each of them, they're their own little unique creature. Some of them you'll find a little bit easier than some of the others will be more challenging. Your test for Chapter 4 will contain 3-word problems. 2 of those you will be required to do. You're allowed to pick your 2. The third one will be a bonus problem that will, if you choose to do all 3 problems, you're going to be able to add on to that. And I'm going to make that a significantly large bonus. It's going to be a 10-point bonus. So there's some incentive out there for you to take the time that is necessary to understand some of these problems. There'll be problems that you have to think about, but they'll be straightforward word problems. So do your best, send me a text. We'll go over a couple more in class on Friday if you'd like to. Have a good week, and I will see you in class on Friday.